Okay, so let's continue with our Kafka Python tutorial series. And in this video, we will look about the schema evolution and schema compatibility, which is like one of the important concept in Kafka. So let's go with that. So what is schema evolution and schema compatibility? But before that, let me quickly start my like a Kafka cluster because currently it is down. So Docker compose up. So it is going to be started. And let me quickly check localhost 8080. So my Kafka cluster is up and running and there is no topic and there is no schema registry. So currently, whatever the code we have right till now, so let me show you. So let's put the Avro producer code, right? So in the Avro producer code, what we are doing is we are registering the schema. So we have the schema in the Avro schema defined, which has user ID, first name, middle name, last name. And we are registering this schema into the schema registry, right? And okay, so let's run this code. So without doing any change, I am just running the existing code, Avro producer.py. So you could see my schema has been registered successfully and test topic has been created. And let me insert some record, user ID 1, some first name, some middle name, some last name, some age, and some email ID. And I have inserted the record, right? And if I go to the topics, and if I go to the topics and click on the message, so my message is there. And if you click on the schema registry and click on the topic, so you could see there is a version defined and there is a schema ID defined for the particular schema, and we have the schema. But let's suppose, so you have working on this project, right? But now the business requirement come, and the business requirement come is either maybe some requirement comes like you need to add some more field, or maybe you need to delete some field. All right, so let's suppose the business requirement is going to come, you need to delete this field. Basically, schema is going to be evolve. So what is the schema evolution? Schema evolution making changes to the structure or definition of the data schema over time. This could include adding new fields or removing existing field or modifying the data types of existing one, typically in response of the business requirement of the application. So what is schema evolution? Schema evolution means, so you are working on some projects. So currently there is some schema. As soon as the business requirement is coming, you are upgrading the schema accordingly, right? So let's suppose the business requirement come, and business said I don't need the middle name. So what I am going to do is, so I am going to remove the middle name, right? So I remove the middle name, and now I need to rerun my producer. So let me rerun my producer, Abro producer.py. And if you see here, something has been happened. And if I go here and go to the topics and go to the schema registry, right? And still I could see only one version, and still there is a like middle name exists there. But even though I have removed the middle name, the reason is because in our schema registry client, before registering the schema, what we are checking is if the schema already exists, then don't register it. So, but in the actual project, we don't apply this kind of logic. In actual project, we always register the schema, but we check some compatibility concept we will speak about later, but we will always register the schema. So what I am going to do is, because I just rerun the Avro producer code and my latest schema did not register here, right? So let's put the business requirement come, and I rerun my producer, but that business requirement did not get reflected into the schema registry, right? Why it is not going to? Because when it tried to register the schema, it found schema already existed, and that's why I am like it's printing schema already registered, right? So what I am going to do is, I am going to remove this if condition, right? So I'm going to remove this if condition and just try this. That's it. And remove this as condition as well, right? So it means whenever it comes to the registered schema, it is always going to register the schema, right? So now let me try that. So let me close this, and now Python Avro producer.py. So you could see schema registered successfully. And now if I come here and go to the schema registry, test topic, so you could see I have the two versions. So version one, which has a schema ID one. So version one has the middle name. And if I click on the version two, which has a schema ID two, and version two doesn't have the Version 2 doesn't have this the middle name. So we have evolved the schema. So what is schema evolution? Even if you click on the official link, so there is the schema evolution and schema compatibility official documentation. So what it says, schema evolution make changes to the structure of the definition of the existing schema. So what are those changes? Either business side, can you add this new field? Either business side, can you remove the existing field? Either business side, can you change the data type? So maybe it was integer, can you make it string? So this could be the business requirement. So this is called the schema evolution. All right. Okay. Now, what are the challenges with the schema evolution? Okay, before that, I am going to show you one thing. So if you come here, if you come to the schema registry, I am registering the schema. Either it's version 1 or either it's version 2, right? So you could see format is Avro, which is fine because we are like registering the Avro schema. Version is also fine. As soon as the schema is getting involved, new version is going to be assigned. All right, and you can see the difference as well, like what was the difference, which is fine. But you could see there is a one more field, that is the compatibility, and currently the compatibility is set as a default. All right. So what is this compatibility? So we are going to, so that is the main concept. We cover schema evolution. Now we have to cover the schema compatibility. What is compatibility? So compatibility means, so let's suppose, let me go to the diagram. So let's go to this diagram. So we have this Kafka broker, right? And we have this topic, we have one topic, we have some producer, we have some consumer, we have the schema registry. Let's suppose we have one producer, right? So we have this producer which we just run, and we have this producer, and this producer has first name, last name, middle name as well, and it is going to register the schema. So it is going to publish the schema. When it is produced the data, so the data needs to be serialized. So before serializing, it need to retrieve the schema from the schema registry, and it is going to publish some records into the Kafka topic, right? So now whatever the records has been published in my Kafka topic, you could see it has the middle name, right? So it has the middle name. And if I spin up my consumer as well, right? So let me change to the earliest. Let me open the Avro consumer. I think the setting is set as the latest. So let me set to the earliest so that it should consume all the records. Python Avro consumer.py. So you could see it has consume the record, uh, user ID, first name, last name, age, email, but it did not consume the middle name. It did not consume the middle name, right? So why it did not consume the middle name, even though we have the middle name? The reason is because now we have published the latest schema. Now we have the published the latest schema, and the latest schema doesn't have the middle name, and the consumer has been started after publishing the latest schema. So consumer able to read the old data as well. That is, consumer able to read the old data which was published using the previous schema. So when this consumer has been started, so let me again go to the diagram. So when this consumer has been started, so it fetch the schema. So when it fetch the schema, it fetch the latest schema, right? So it fetches the latest schema, and the latest schema doesn't have the middle name, but now it has to read the messages. So when it read the messages, it wants to deserialize it. So it has to deserialize based upon the schema. So in the schema we have the age, in the schema we have the email, in the schema we have the first name, in the schema we have the last name, we have the user ID, but in the schema we don't have the middle name, right? So it did not deserialize this, and remaining fields it able to show you. So it means the new consumer able to read the data which was published using the previous schema, right? So it means it is compatible, right? So it means it is compatible. So there are, let me again go to the schema compatibility. So this ensure that changes made to the schema maintain compatibility for both old and new data, allowing data produced with different version of the schema. So what exactly it means is, whenever, so in the Kafka, there are three concepts only, right? Producer, then Kafka, and then the consumer, right? So let's, because this diagram may be complicated for you, so let's try to learn in very simple way, understand in simple way. So we have the producer, right? So you are running some application. Your application is producing the record with first name, middle name, last name, right? So you are continuously publishing the records. You are publishing continuous the record, and there is a consumer always up and running. So consumer also consuming the record. So consumer also consuming the email first name and last name, middle name, right? So consumer is up and running. Now the business requirement come, and business requirement say that can you like remove the middle name, right? So you remove the middle name, and now you started publishing the records, right? So now when you publish the record, so let me publish the record. Let me publish the record. So user ID, first name, and so middle name is like why it is asking the middle name because of the code, but it is not going to publish. And some email. And if I go to the my Kafka cluster, so you could see now my second record has been published and it doesn't have the middle name, right? It doesn't have the middle name. So now your business requirement has been come. So in the initial stage, you created one application uh, with some schema, and initially the schema is, let me again show you. Initially, the schema is user ID, first name, middle name, and you are publishing some data. You are publishing some data. So the data has all these fields, and you have some consumer already running up and running, and your consumer is perfectly consuming the data from past 6 months. All right. So now after 6 months, business requirement change, and now the business said, can you remove the middle name? Now you remove the middle name. Now you have removed the middle name from the schema. So now you are publishing the record. So whenever you are publishing the record, uh, you are you are publishing the record without the middle name, right? But can consumer able to understand this schema now? All right. So can consumer able to understand this schema now? So that is a very important concept. So this is called as a compatibility. This is called as a compatibility. So because we can't, because there could be 1,000 consumer, there could be 2,000 consumer. We can't going to say all the consumer, can you shut it down and can you restart your application to fetch the latest schema? No, we can't say that. So we have to make sure our schema should be compatible inside. Whenever we do any change into the schema, it should be compatible in such a way so that the existing consumer should not be impacted. Even though we are publishing the record with middle name, either we are publishing without the middle name, so consumer should able to uh, consume this format as well, and consumer should able to consume this format as well, right? So this is called the concept of the compatibility. So now if you read this term, schema compatibility, this ensure that the changes made to the schema, changes made to the schema maintain compatibility with both old and new data, allowing data produced with different versions. So data has produced with two different versions, right, of the schema to be processed seamlessly so that the consumer should not face any issue. It should be processed seamlessly. Compatibility ensures that the consumer can handle data produced with different schema version without error or data loss, so that the consumer can consume the data without any error loss. So that's why like this diagram is, uh, there is an old producer means the producer which was publishing using the old record. Now there could be new producer which was publishing with the new schema. There could be the old consumer and there could be the new consumer. So there could be like that, uh, there could be one consumer which was already up. There could be the new consumer which just come after the 6 months, right? Okay, so now we have to go to the compatibility level. So there are a couple of compatibility level. Let me open the official documentation. So not this document, but this document. So if you scroll down, so there are now 1, 2, 3, 4, 5, 6, 7, 7 compatibility levels. One is backward transitive, one is forward transitive, one is full transitive, one is none. Right. So what all are those? All right. So whenever we are doing any change now, so as an example, before jumping into the schema compatibility, let me show you one thing. So let's go to the our Avro schema. So currently we have removed one field. So let's suppose there is a requirement to add one more field. Add one more field. So let me add one more field. Let's suppose address. An address is a string. So let's suppose there is a one more requirement to add one more field. Is it going to be published? All right. Is it going to be published? So let's see. So let me start the Python producer. So now you could see I am getting there a schema being registered is incompatible with the earlier schema for subject this topic. Now our schema is not compatible with the earlier schema. So that's why that's why we have this field compatibility level. Let me go to the schema registry. So you could see we have this field called the compatibility level. Right, so by default compatibility is level default. So default means compatibility level is backward, because I could see there are multiple compatibility levels. One is backward, one is backward transitive, one is forward transitive, one is full transitive, one is none. So backward is our default compatibility level. Even you see compatibility level is backward, and which is our default compatibility level. So default means backward only. Even if you see default, it means it is backward compatibility level. Now you could see when I remove some field, then it is successfully able to publish the record. But when I add some field, it is not even able to publish my latest schema. It is not able to publish my latest schema. So why it is so? It is not able to publish my latest schema. Even if you go here, only there are two schema, right? There is no third version in which I have added the one more field called address. Why? Because schema registry, this compatibility level check whether the schema you are going to publish is compatible or not. Because if the schema is not compatible, then consumer is going to face the issues. Because if I am going to publish some record, let's suppose my schema registry able to publish the data, able to publish the schema, this schema, address schema. If it is going to publish that now, then my consumer is going to face the issue. Why my consumer is going to, because when it's going to serialize this address, and it is not able to find the address field in the old data, so it is going to face the issue. All right, so we have uh, seven concepts. What is happen? One second. So we have seven compatibility level. One is backward. So backward is the by default level. So in the backward, we can either delete the fields or we can add the optional fields, right? So that's why by default we have the backward compatibility level. So that's why when I delete the field, delete means when I remove the middle name field, it is successfully able to publish, because the backward compatibility says either you can delete the fields. So what are the changes allowed in the backward compatibility? Right, so I can delete the fields, so which we have already tested. Or if we have to add the fields, like in case we are adding the field, so it should be optional. So it should be optional, maybe like it should be either this type. It should be optional. It should be like of union type string and null. Now if I run this, so it says schema incompatible. Why it is still saying? Maybe we need to do the default null. Okay. So you could see schema has been registered successfully. And now if I go here and if I refresh it, so now you could see my third schema has been published, and now we have the field has also has been published. So in the backward compatibility, if you are going to add some mandatory fields, then it is not going to be allowed, because that was not compatible. Because now if I am going to publish this data, and if my consumer is there, and if this data has to publish which doesn't have the address, then the consumer which has the address, but one consumer is already running, which was running using the old schema, and old schema doesn't have the address, but the data which is coming that has the address. Right. So consumer should able to understand the old data as well. Consumer should able to understand the new data as well. So that's why the compatibility level come into the picture. So what is schema evolution? Schema evolution is just a normal concept to change the schema from time to time based upon the business requirement. Schema compatibility means if you are doing any changes, you have to make sure schema should be compatible. You have to make sure schema should be compatible. You have to make sure consumer should not be face some issue. Consumer should not face any error. So that's why we have the schema compatibility concept into the picture. So by default, it is backward. Now in the backward, either we can either we can delete some field or either we can add some field. But what exactly backward means? So what exactly backward means? So let's see the backward. Okay, so backward compatibility means that the consumer using the new schema can read the data produced with the last schema. As an example, so let's suppose I have the producer. I am producing some records. So let's do in practical. Let's do in practical. Let me stop this. Now let me make this quickly up and let me go back to my schema and let me remove the address field and let me add the middle name field, which was my initial. Because by default is backward compatibility, but what the backward compatibility means, we have to learn that. So this is our normal. We are not doing anything, just this is our normal, and we have to publish some records, right? So python avro uh, producer.py. So schema has been registered, and let me quickly start the consumer as well. So my consumer has been started and my producer has been started. So it means, let's go to the diagram. So my producer has been started. So this producer has been started and my consumer has been started. My producer has published the schema, right? And my producer has published the schema, but it has yet to be published the record, but it has published the schema. So let's quickly look at the schema as well. Retry. So my producer has published the schema and which has the middle name. So now let's publish some record. So insert one, some first name, middle name, last name, age, some email address, and insert first name, last name, age, some email address, right? So I have published two record, and if you go to the consumer, so it is consuming the record, which is perfectly fine, and it is consuming the record with the middle name as well, which is perfectly fine. Why it is consuming the middle name? Because when this consumer has been started, it read the schema which is available, and this schema has the middle name, so which is fine. So till now compatibility level doesn't come into the picture, right? But now let's pause. Now let's pause. Business requirement come, and the business requirement say kindly remove the middle name. So I have removed the middle name, right? Now I have removed the middle name, and so now I will publish the records again. So now schema has been registered successfully. Schema has been registered successfully. You come here. Schema has been registered successfully without the middle name, right? Now let's insert some record, or don't insert some record, because we are checking the backward compatibility. So now schema has been registered successfully. Now let's suppose there is a new consumer come into the picture. So so this is the new consumer. Let me change the group ID, and now let me start the consumer. So Python avro consumer.py. So this new consumer has come into the picture now. Now new consumer able to read the record or not? Yes, it is able to read the record, because when the new consumer has been started, all right? Because if you go to the consumer code, we are using the avro deserializer, which is reading the schema from the schema registry client, right? So what it is doing at the backend is, let me go to the topics. All right. So it has found two records which has age, first name, middle name, last name, because this was published using the old record, and it has no issue with the old consumer. So this is my old consumer, and this consumer was up and running using the old schema. But my business requirement has been changed. Now business requirement has been changed, and it has published the new schema, which is fine. So now in my schema registry there is a new schema. But now let's suppose one more consumer said I also want to consume the data from the topic. Right. Now in my topic I have the old records. Old record means the records which has the old schema, and but in the schema I have the new schema. And now consumer come and consumer said I want to consume your old record as well. But when the consumer has been started, first it is going to fetch the schema. So it fetch my latest schema. It fetch my latest schema which doesn't have the middle name, but the records has the middle name. All right. But still it is able to successfully process the record without the middle name, because it has only see user id, first name, last name, age, and it doesn't even read the middle name. Why it doesn't read the middle name? Because it did not deserialize that middle name. But it is successfully able to read the records because the business requirement has been removed to get the middle name. So that is fine. So consumer is don't read the middle name, and it is able to successfully able to read the messages which was published using the old schema. So this is called as the backward compatibility. So backward compatibility means the consumer using the new schema. So this is my consumer. Let me rename the window. New consumer, and this is my old consumer, and this is my producer. Right. So backward compatibility with the consumer using the new schema. So consumer using the new schema can read the data, can read the data, so can read the data. All right, so can read the data. So this data, which was published by the last schema. So which was published by the last schema. So this is called the backward compatibility. Now the easy way to remember is you can just instead of the backward, just to remember that you can remember like backward data, forward data, backward transitive data. So backward data, back generally in the English, what is the backward means? Backward means we have to go like back, and backward data means the data which was published earlier. So backward data means the earlier data. So what is backward compatibility means? So can consumer able to read the earlier data or not? So that is called the backward compatibility. So in our schema registry it is set as the backward compatibility level. All right. And it is set as the backward compatibility level, and we have tested that as well. And so now we have the producer, we publish the record. So and so the old consumer uh, was when it used the old schema, it is able to read all the five fields. And when we register the new schema, and then the new consumer is going to be up. Still it is successfully process the old records but without the middle name, but it is read the main thing is whether the consumer is in the error or not. So the consumer is did not in the error state. Consumer successfully able to read the record, doesn't matter whether it able to read the middle field or not, but it is able to read the fields. So that is called the backward compatibility. So how you can run that, because generally people get confused with the backward and the forward compatibility. So the easy way to remember is just to add the keyword data when like learning the backward compatibility. So when you say backward data, so backward data means the data which was published earlier. And if the data which was published earlier, so who is going to read? The new consumer is going to read. So can the new consumer who's using the new schema, can the new consumer using the new schema can read the previous data or not? So yes, that is called the backward compatibility. All right, so we have tested that. Now what is the backward transitive? So backward transitive, so in transitive generally in the mathematical means like a follow b, b follow c, c follow d, d follow e. So this is called a transitive. All right. So when I publish this record, all right. So when I publish this record, so before publishing this record, na, so whether this schema has been published or not, schema registry is checking whether this schema has been compatible or not. But with because to comparison, it has to comparison with some schema. So when then this schema has been published, it comparison with the previous schema. That is only the last published schema it has compared that. But if I set to the backward transitive, if I set to the backward transitive, then whatever the schema is going to be published, it is going to check whether I am compatible with all the previous version or not. So that is called the backward transitive. So if you come here, and if you come here and if you go to the backward transitive, so backward transitive, so backward will, before publishing the schema into the schema registry, backward compatibility check whether I am capable, or I am compatible with the last version or not. But backward transitive will check all the previous version. All right. And but what are the changes allowed? So all the same changes are allowed. And what is the backward compatibility? Backward transitive compatibility, whether the new consumer with the new schema able to read the backward data or not. Backward data means the data which was published using the previous schema. So that is the backward compatibility. Now, what is forward compatibility? So before reading the forward compatibility, if we have to test the forward compatibility, right? So we have to set here forward compatibility. So, but how we are going to set this? How we are going to set this? So first we have to write some code to set the forward compatibility. So let's go to the official documentation and go to the schema registry. And here there is a one function. So there is a one function called set compatibility. So this is a set compatibility. So let's write this code. So we are going to write the code into the schema client registry. Let's write some code. Def set compatibility. Try. So now what is the logic? So we have to use this client. Which what is the function? The function name is, so what first string is the self dot. Function name is set compatibility. All right, so set compatibility, and it is going to take two arguments. One is the subject name, but that is the topic name, and the compatibility level which you are going to set. So what is the subject name? Subject name is this one, self dot subject name, and compatibility level we can pass. We can pass, and now we can print schema compatibility has been set to compatibility, and then except it is going to give only one error, that is the schema registry error. If it is not compatible, as E, we can print schema is not compatible. All right, and we can do exit one. All right, now we have to call this function. So in the Avro producer, when we are registering the schema, before registering the schema, we are going to set the compatibility level. So set compatibility, and we have to pass compatibility level. So now we will pass forward. In the backward, why we have not used this function? Because backward is default. Either you call this function or not. So now we have the forward compatibility. Okay. So now let me stop everything. Let me down it so that I can remove the old data. Docker volume prune hyphen a. Yes. Now let me make the cluster again up. So cluster has been up, and let me go to the my Avro schema, and let's put in, and let me again put the middle name. So now I am going to register my schema with the forward compatibility. Why I am going to register the schema with the forward compatibility? So that if there is any change coming to the future, that is adding the new fields. All right, adding the new fields change to come into the picture, so that that can be incorporated easily. But before that, like just normally our normal code, Python arrow producer.py. So you could see schema compatible header has been set to forward and schema has been registered successfully. So let's verify that and go to the schema registry. And now, uh, so you could see compatibility level has been set to forward. And why it is showing backward here? So let me refresh it. It is showing backward here, but this is not the backward. The compatibility has been set to forward. So if you see here test topic, so in the particular test topic, compatibility has been set to forward. All right. So compatibility has been set to forward, but what exactly forward means? So what exactly forward? Forward said you can add the fields or you can delete the optional fields. All right. So in the backward means going backward. So whatever you have added, just remove that. So that's why in the previous video we have removed some fields. Now in the forward, we have to add some field. But before that, let me publish some record with the existing data. With the existing data, let me publish some record. Insert ID and let me start my consumer as well. So consumer like successfully able to why okay I have published only two record I think. Let me cross verify. Yeah, so I have published two record which has like this structure, right? So which has this structure and my consumer has successfully able to read the data. So which is the normal behavior, nothing related to the compatibility level, right? So now we have set the forward compatibility, but whether this is actually forward compatible or not, we know it's forward compatible because if it is not forward compatible, then it is not even able to register the schema. All right. So now let me. So now let's suppose the business requirement come and the business requirement said you need to add the address field as well. You need to add the address field as well. Address field as well. So now I have added the address field, but here there is a one catch. We need to pass the default parameter as well, because if you are not going to pass the default parameter, the existing consumer is going to face the issue. So we need to pass some default parameter. So let's suppose the default parameter is my address. So this is my default parameter, right? So now whether I am able to add the new field or not, right? So let me stop my producer and now Python arrow producer.py. Schema has been registered successfully and go to the topic, go to the schema registry. So you could see I have the second version and in the second version I have the address. All right. So schema has been registered successfully. Okay. But we have to test that. First, we need to understand what is the forward compatibility. So forward compatibility means consumer with the previous schema can read the data produced with the new version. So to learn this, just consider forward data instead of the backward means backward like how to learn the backward data means whatever the data you have already published can be it read by the new consumer, so backward data. Now now the thing about the forward. Now the thing about the forward, so forward means forward data. So whatever the data I am going to publish now, whatever data I am going to publish now, all right. So but before that, I have to change my code because now we have the address field. So Abro producer. So let's take the address as well. And address. And we can pass the address. We can update the user class. self dot address is equal to address. We can pass this parameter and we can create a dictionary as well. User dot address. Right. Okay. So let me start my producer to publish the new format of data. But my old consumer is still running. You could see my old consumer is still running. So old consumer only aware about my old schema, not aware about my new schema. So let me publish some record. Email address. All right. So now it has been published. It has been published. But whether my consumer has been able to read the new records or not. So yes, it is able to read the new record as well. So this is called as the forward compatibility. Forward compatibility means forward data means whatever the new data means within the data with the new schema which we are going to publish, whether that was read by the old consumer or not. Because if you notice here, this has the address field as well. This has the address field as well. This has the address field as well. If you are not going to set this forward compatibility, backward compatibility, na, then our consumer will face some issue. Our consumer is going to give some error. Why it is going to give some error? Because you are giving the address field. So with my application was running right from past 1 year, and from past 1 year I am publishing the record with the address, and from the past 1 year there are 1,000 consumer which were up and running, and they are consuming all this data, and their application only processing this field. Now suddenly the business requirement come, and the business requirement said, can you publish the data with the address field as well? So this is just the business requirement, right? Just to add, just to pass the address field, but it is not a business requirement at the consumer side to parse the address field, right? So I need to make sure, if I am publishing the data by passing the address field, the existing consumer which was running from past 1 year, there are 1,000 consumer which was running from the past year. I am not going to drop an email to all the stakeholders, all the consumer. Can you restart your application? No, they are not going to do that. So they are running. If they have to consume the address field, then definitely they have to restart their application to consume the latest schema. But if there is no requirement and the consumer and they only just care about the user ID or the middle name or the first name, they don't care about the address. And so we have to make sure the existing consumer should not be impacted with our the data, whatever the new data which we are going to publish, existing consumer should not be impacted. So we have already tested. So when we set the compatibility level to the forward and we added the new field, so in the backward we deleted field, in the forward compatibility we added the new field, and the old consumer still able to read my new data. The new data means the data which was published by the new schema. Correct. So this is called as the forward compatibility. And what is forward transitive? Forward transitivity is also same, same as the forward, but transitive means, because whenever we are publishing the data using the forward compatibility, so whenever the version 2 has been published, so before publishing the version 2, it's checked with the version 1 whether I am forward compatible or not. When I set the forward transitive, so if I publish the version 3, version 4, version 5, so let's suppose when I publish the version 3, so version 3 is not only going to check with the version 2, version 3 is going to check whether I am compatible with version 2, version 3 also going to check whether I am compatible with version 1. If any of the compatibility is going to fail, it's not going to be published. So forward transitive means it has to be like compatible with all the previous version, and forward and backward means just the last version. It should be compatible with just with the last version. Okay, what is full? What is none? None is very simple. We are if we just pass the none, then we can add any fields, we can delete any field, we can like delete the data, we can change the data type, right? So this is generally not recommended. This is only recommended when you don't have any consumer, when you don't have any consumer, because if you use the none, and if you use the none, so what was the issue is going to become with the none. So let me show you what was the issue going to become. So let's suppose my consumer is running, all right? So my consumer is running, right? and and I am going to set the compatibility level to none. Let's suppose I'm going to set the compatibility level to none. But before that, let me stop my, so that I can clear the old records. Okay, so let me stop this. So our Kafka cluster is up and running. Go to the topics, and there is no schema. So let me publish that. So schema has been set to none. All right. So compatibility has been set to none. If you refresh it, so you could see compatibility has been set to none. So this is very dangerous compatibility, which is set has been done. And let me start my consumer. Python avro consumer.py. And let's suppose you are publishing some record. One, some email, right? And some address. So this record has been published, and this was also consumed by the consumer. So consumer said, okay, I read the user ID, first name, middle name, last name, and everything. But now let's suppose the consumer is still up and running, right? Consumer is still up and running, and now let's suppose I want to I want to like add some more field. I want to add some more field. All right. So maybe favorite color. All right. So I have like add the field like a favorite color, right? And now let me publish the again avro producer.py. So I will insert the but before that I need to update the code to pass the favorite field, or instead of the favorite field, let me remove the middle name. So I have removed the middle name, right? And now let me publish that. So insert user ID, first name. So middle name is just why it was asking, because it is in the code, but actually it's not going to publish. Some age, some email address, some address. All right. So message size is this. All right. And if you go to the topic, so you could see my data has been published, but whether the consumer has been able to consume it or not. So is this the data which we have published? I think schema has not been published. Schema also has been published with the two. Okay, schema has been published, but it's still their middle name. We have removed the middle name. Why it was not published? So let me again run that. Python error producer. Okay, so it said it says invalid value. So that's why I'm saying why it was published. So what was the invalid value? Something is wrong. Okay, so let me remove this comma. Python error producer. So you could see my schema has been published. So now the third schema has been published, which is the third version. And now I have removed the middle name. But my consumer, which was running, it expect the middle name, right? Because when this schema has been started, that schema wants the middle name. Now I have I have like updated the schema, and I have not, because the compatibility level is none, so it is allowing me to change anything, so which is very dangerous. So let me insert some record. So middle name just is asking, but it is not going to publish. So just let me go here and topics, and you could see I have published the record, right? I have published the record. But if I go to the consumer level, see my consumer has been broke. My consumer. So this is the issue. That's why compatibility, schema compatibility is very important. So why it got broke? Because this consumer, when started, it consumed the schema. And when it consumed the schema, it has the middle name. Right? And now I am publishing the schema. I am publishing the schema. I am publishing the schema. All right. With the where the schema registry. I am publishing the schema with the compatibility level as a none, which means I am doing any changes into the schema without worrying about the consumer. So which is very dangerous. So you should never use compatibility level as a none. So you can use as a none when there are no consumer. But when there are consumer use, you should not use the compatibility level as a none. Because if you use the compatibility level as a none, and if you do any schema change, all the consumer is going to be impacted, and they will start like raising the production incident. All right. So that's why this compatibility level is like important when we have to use backward, when we have to use backward transitive, when we have to use forward. So if you worry about, whenever you are doing any changes, if you worry about, you should worry about all the previous schema, then you can use the transitive. Because why you worry about the previous schema? Because you don't know which consumer is using the which schema, right? So in that case, you can use the transitive. But if you are worried about the forward transitive, you can use the forward transitive. If you are worried about the full, then you can use the full as well. So full means it is applicable for both. It is the just combination of the backward and the forward, right? So and the full transitive, same, it is going to compare with the all the previous version of the schema none, which is very dangerous. It means you are disabling the schema compatibility, and you are publishing whatever you want. If you are going to publish whatever you want, all the consumer are going to be impacted, right? So that is very important topic. This is a little bit you can say maybe confusing sometimes, right? So the easy way to remember is just add the keyword data behind the backward, just add the keyword forward behind it. So backward, when you see backward compatibility, maybe you get confused. So if you just add data keyword, so backward data means whatever the data is going to publish earlier. Earlier means by the old schema. Can this be used by the new consumer? Because old consumer definitely able to read that, but can it be able to use, consume by the new consumer? So that is the backward compatibility. What is forward? So add the keyword forward data. So forward means the new data which we are consuming. So the new data, new consumer definitely can be consumed, but can the new data consumed by the old consumer or not? All right. So that is the forward compatibility. All right. So that's it. That's the end of the video. And thank you.